Hi all, this is Claudio from sptfea.com with another live stream with fundamental analysis in ansys workbench. Let me share my screen firstly and position my microphone closer. All right, so a quick reminder about our website where you can find lots of tutorials, already solved simulations, books, webinars, and also live FEA support. So I opened Space Claim and I would like to drag and drop something on the topic that today is the impact of a drone, unmanned aerial vehicle, into an office. I said a room, not a building, all right? Let's not aim too far, too high. Let's go with the simpler things. I'm looking for the office. I found on GrabCAD some models. Who even here? Another one. And let's also drag and drop some drones. I looked for simple drone versions. This one looks nice. Okay, we'll keep this. Now let's look for the office. The problem with this is we have some slender pillars, let's say. What I would like is to have something like this, to have more rigid parts here. So let's go with what I said. I will close that geometry and I will insert this drone. Copy here and paste here. Let me insert it. All right, here. Just for fun, what are the general dimensions for a Reaper drone size, for example? Do we have? This is feet, I think. Come on, give us some values, please. No values? Oh, we have values. So, for example, the wingspan is 20 meters. Come on. This would mean that it's bigger than my office. This office, I mean. This office is, the container is around 6 meters. So let's make this, I don't know, maybe 3 meters or something like this. Let's scale it. Design, pool. This is the scaling button, scale body. I will select the geometry. This is the geometry. And I didn't read it. It needs an anchor point. This is an anchor point and this is the geometry. How small should we do it? This could be interesting. Let's leave it like this. And we will try and fit it somewhere through the door or through the window. Let's see a little. So I'm using the move operations. Yes, this looks nice. Maybe a little more horizontal, let's say, something like this. And yes, let's get closer to the impact location. Something like this. All right. So the option that we have is: do we need to leave this furniture pieces? Let's hide the container if possible. Hide. Come on. I'm not really interested in this plate. Also the drawers, they are too detailed, drawers. This is embedded in this foot. Let's hide this leg of the desk, this leg. It's embedded here. You know what? Let's just delete this. Show all. Let me hide again this and this. In this leg, I would like to delete it because I was thinking about mirroring what we have here. Mirroring. Do we care so much about these legs and this office? And no, let's just delete the corner. Triple click for to select the body. Also the remainder of what we have here. So I got rid of that office. We will have these. Can I move them? Yes, it's easy to move. Triple click, and I'll let's firstly rotate it with 100 degrees. I see they are patterned, I think, because everything rotated. It didn't select the entire chair. I have so many details here. So we have this chair. I have the so-called container chair. What? Container, what? Container desk. Container cover, desk window, yes. All right, let's rotate these with 180 degrees. And bring them closer to the entrance. We need to leave some room for persons to enter the container. Also, we need to think about overweight persons who want to enter the container. I would like sincerely to get rid of this chair. Let's see if it's possible. The focus should be on the impact of the drone and not... right click, make independent. What? What is the double? What? I don't know. Can I delete? No. Can I make this independent? All right. But can I move it? I can move it. Okay. I want to leave space for persons to enter the office. Should I make independent? All right, make independent. Let's see if it works. Ctrl Z, delete. Why? Because I'd like to copy what we have here. All right. Let's see. Can I hide this? Not so much hiding. Right click, locate in structure tree, and I would like to move them here. Why this didn't catch? Ah, there is this. What is this part? All right, I said I would like to move these closer to the window. With Control pressed, I will copy this to the other window. All right. Now we have everything what we needed. Chair. Let's move the chair here. All right. Right click, move to new component. This will be a chair. And this is another chair. Here, this one. All right, let's leave it like this. Let's hide these chairs and these desks if possible, because I'd like to merge some of the container. There are too many parts in the container. Let's also hide the drone. Do we have something? Any sign from the audience? Let's see. No sign. Okay. We like silence. Firstly, let's right-click Source Internalize All. Right-click Delete Empty Components. And save it. Save as drone and office container v1. All right, we do have some, I don't see the necessity now. These blinders, or how they are called, search all bodies. All bodies with volume, yes, just there are some stiffeners here. Same color, oh. So this goes inside. What is this? This is like a frame. Do I care about this? Let's leave it. All right. If I hide this, what will show? Ooh. It's a nice. It's a nice model. It's a nice container model. Nice container model. Do I need so many parts on this container? So this goes here to support the door. This collides with this. What happens if I hide here? The door will be a little in the air, but we don't care so much. So show all. Let me hide the door and what is this? Sincerely, I would be satisfied with only this for the container. This means, let me triple click here. What? Come on. This is the desk, and this is the desk, the chair, everything. I would like also to hide the drone. And you know what? I will delete all of this. Right-click, locate in structure tree, delete. Delete components. Right-click, show up. Oh, this would be so nice. Except there is no door. Do we care about the door or not? We already have a door. Come on. We don't care. We don't care about the door. We already have a door. What we can do in order to get rid of these hinges, we can cut the container. I selected two parallel faces, and in their middle, I will create a plane, this plane. I will set body. It requires the body to be split on the plane, and I will remove. Oh, it's not possible to cut it. Is it? Is it true? I cannot split it. Where is the container now? This is the container. All right. Just for fun, can I create a rectangle big enough to cut this container with it? Cut here, and I will impose a negative, yeah, here on this side. Minus, we don't care. It can be 50, 100, 1 millimeters. I want to create the smallest. Cut. Why didn't it cut? All right. It doesn't want to cut. No. Due to there is a problem with the Boolean operation, I think. Can I, don't know, combine, click this and this? No. Unable to intersect bodies. Unable. You know what? Let's see if I can get rid of these features. If I delete, what will happen? Nothing, okay. Let's go even further, you know? Something like this. Come on, please cut. Please cut. You don't want to cut. All right. Yeah. Yeah, it's nice. It's beautiful. What is this? Why do we have this here? All right. You know what? If you cannot defeat them, you might as well join them. So Let's accept the fact that we don't have a wall at this moment. And maybe build something looking like a wall, you know? Just wondering, can I select these faces and pull them up to here? Yes. Let's do the same here. By the way, the FEA will follow in a few minutes, so if you don't have the patience to see this modeling procedure, then feel free to fast forward, to skip. But yes, you'll be missing some modeling. All right, so my proposal was to pull this up to this face. U from the keyboard, U, up to. Ladies and gentlemen, everyone is protected now. We don't have the corrugation inside, but we don't care too much. Let's see if we have all rounds, because I would like to get rid of them now. All right, this is perfect. Let me also remove maybe these cavities. I would like to remove them, if possible. Not so much. Because I'd like to avoid thin elements. Also here, and also this one. So let me pull these faces up to, we press U from the keyboard, here. All right. We don't care about the surface anymore, we don't care about the plane, but it can stay, no problem. Show, yes. Let's make it enter the door frame. Something like this, yes. About these, can I join them? Combine. This is one part. All right. Let me join the chair if it's possible. I don't know if it's possible. Combine this. I'd like to join it with this. Cannot merge. Cannot merge. Cannot merge. This works. Why can I not merge here? Why? Let's just delete that. Let me try and mirror whatever we have here. Right-click, hide others. Let me split this body with this face, and let me mirror what we have here. Mirror this face with this part. All right. Now, right-click, show all. Come on, show me. Show me. This one, all right. So, combine these and these with Control pressed. No, what do you know? All right. Can I just delete this? I can. This one, all right. So delete this and this cut out, and let's move the back, the recliner, the whatever is this. Let's move it towards here. All right, now it should merge. It is merged. Triple click, yes. Right click, what? Right click, show all. And I would like to delete what we have here. Yes, we have this and I don't know. Come on. Right click, delete empty components, this chair and this table. Move with control pressed. Control pressed, and here where the window location, which is the very best. The people can look outside, and you know, clouds, the grass, the roses, the birds. All right. 1, 2, 3. 1, 2, 3. Move. Let's what? Let's incline it a little. Yeah. Something like this. How deep should we make this? This is interesting. Should we make it entering? And it will collide with the back wall here. Maybe I should have kept the door and the window in order to have an impact. But yeah, let's just have it like this. So right-click source intent, and we are going towards the simulation now. Delete empty components. I can drag and drop this here and here. I can click and delete. Why do we have here? Okay. This is the container. I will call it, yeah, container. Why not? I wanted to call it office, but yeah. This is the chair. This is the one of the desks. This is another chair, and this is the other desk. And this is the drone. I will not call it Reaper for copyright purposes. Like Lockheed Martin or Northrop will watch this video and strike me for copyright. Come on. I'm wondering, because I would like not to have this as a solid body. I would like to make it shell body. At this moment, let's leave it solid, and maybe we'll remake the FEA with the solid body. I think I can click here, start ansys workbench, something like this, yes. And I'll have 2 instances of ansys workbench. The first one I will close. This, the first one I will close, and I will work with this one. I said explicit dynamics. Right-click, import geometry data, drone and office container. Only I need to save this simulation exactly on an exact location. This is stream 18, February 25th, drone and office. Yes. Now everything moved on the path that I would like to have. Let's double click model in order to import the 3D. Then I will close space clean. Something happened here on the, no, perfect. I think we have 2 people, hello, 2 people watching. Let's set up and watch the impact unfold. I heavily simplified our geometry because we need a proof of concept. In your proper project, thesis, research work, you'll keep all the necessary parts. Here is it's just a lesson. So I'd like first of all maybe to fix these. This is the first thing that I'd like to go. All right, let's save this. And I said that I would close this. I would close space clean. What materials do we need? Aluminum, 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 steel. And the desk is part metal, part wood. Yeah, everything aluminum, including the drone. And this is steel. And that is all. So let me delete the default steel. And I always advise to go with nonlinear materials, either from this library or from the explicit dynamics library. Structure steel. All right, right-click here, refresh materials. Now, let's assign everything to be out of material or of aluminum, and this structure steel, non-linearly defined. Non-linear defined means that we can see what happens after the yield point. Look here. Here is the region where plasticity occurs, also for structure steel, the same. It differs, the point, the yield limit differs between these two, let's say. Also the strain, yeah. So the strain is much higher and the strain is lower here, the ultimate strain. Where are we? Here, contacts. Do we care about contacts? Meaning, do I need something bonded or no? Let's leave them having this default frictionless interaction. Only I know that customize it a little. The friction coefficient between aluminum and steel is usually 0.5 or higher. So I was wondering, this and this 0.5. Yeah. Let's assign, as I said, 0.5, and I think a similar coefficient can be applied here on the dynamic, but let's leave it like this. Curvature, no, and quality, low. Smoothing low here. Let's generate a default mesh and see how it will look like. Oh, yes. Firstly, I would have liked here to have virtual topology. Right-click, generate virtual cells in order to unify corrugated faces. Yeah, not much unification, but at least we gained some optimization on the drone. All right, so here, instead of 269, what will happen when we assign 100? Just out of curiosity. All right, instead of adaptive sizing, let's make it yes. Here, maybe 2. Resolution, transition, fast. Right-click, generate mesh. What do you know? What do you know? 60,000. If I make it finer, then I will exceed 100,000 nodes. And I don't want this. I'm thinking about making this container out of shell body. What for here for resolution? We have the feature size. How much should this be? I don't know. 5 millimeters. Let's see. Come on. All right, I'm contemplating the idea of having another office room. Maybe I will also keep the furniture. even though the chairs didn't mesh. Let's keep these with 100. And change only here. I open Space Clam because I'd like to take a look at another office. I have the thinner one. You know what? It might be acceptable. Why not? I don't understand here what's happening. What? Oh. Mm-hmm. Yeah, let's not waste too much time on this. This could be usable. What? So double click on the geometry and let's insert the other office building. Hide others. Can I do something to optimize here? It has lots of programs. Look here, lots of programs. Should I also here? Can I delete these rounds? Let's see if it works. Come on, cooperate. And there is no easy way to select the outer shell. Maybe there is this way. And what's the advantage? We can have this shell, and it looks nothing like what we have planned. All right, let's drag the other room. I'll take a sneak peek here. drawing, no. And this is the part, but how useful is this? Let's see a little. I will explode it a little. Too well made. And sincerely, I don't need so many parts because we want to go for meshing, don't for FEA. We don't need to spend so much time on modeling. What is this? Oh my god. This is SketchUp. Let's see if it opens. I didn't work with the SketchUp files until now. Alright. Here, what is this? This is a step file. And that's all. Ooh. You know what? Let's save it for later. What is this? Bitmap. And drawing. Come on. Give us 3D models. Oh, this could be interesting. Very simple. This one. Who wants STL? There are no more windows. I know it's easy to make some cutouts, to have windows, but all right, so let's open. Here I will choose all supported files, and we have to logistic office SketchUp. Let's see. What? All right, and the other one was elevator, shaft roof. It's the big building. This is the big building. I have here a thing called simple building. Do we need it or not? You know what? It's so simple. Let's use it. -90, right? 90 degrees. All right, let's make it transparent and let's look from above. Okay. Can I move this? Copy paste, I meant. Let's make more. Such offices, such desks, in order to pretend that everyone is working. All right, so or each one in front of each window. Yeah, why not? They need to enjoy the green grass and the chirping of little birds from the outside. All right, so let's make this flat because of the drone. Move here. Design, split body. This one with this plane, and I will remove this thing. This I don't need at this time. Let's click these four sides and click here, fill. Once I click here, fill, we have two surfaces. And I will pull up. How much should I pull? 70. All right, so this is the office building. Now we have a drone. All right, for uniformity and conformity's sake, this looks kind of how it should look like. It's kind of empty, you know, but yeah, let's do it. Do we leave a small inclination? Let's leave a small inclination, and we will insert it on in a window. So let's say that someone targeted that person. Hopefully it's the proper person, not the colleague. You know what I was thinking? Why should we have 5 windows? Why? using so much mesh, there will be let's split this body with this face. Let's delete this body. Let's delete these chair. This is now part of the building. Oh, the desks are now part of the building. So let's firstly let's remove these holes, and let's remove this thing. Okay. So I will split this body with this surface in order to have separate parts. Now let's join this with this. Yes. Now this is desk. This is desk, and this is the building. All right. Control S to save. Let's move a little things. What we have here. I selected the door frame, door cutout, because I would like to move what we have here. Maybe something like this. All right, let's create a wall, fill, and I will select these two surfaces -70. All right, we have a wall, we have an office, right click, and it enters on this side. All right. Now, because the inclination is like this, let's move this towards this this other window, because I'd like to have something like this. You know, the order, the position in office can vary, so don't be so strict, please. Everyone can move their chairs however they like, so please don't be critical of other people's preferences. This one and the door will go here. All right, so have this. Hopefully it will touch the desk and the chair. Something like this, yes, hopefully. So Control S, let's go again. I don't know about these chairs, if they will mesh some time today. Chair, do we have something? A very simple chair? Something here? Nothing. Okay. So a very simple chair, but not ridiculous. This could be interesting. Ooh, I like this one. The purpose of this FEA should be part of the draw, not the furniture. So this is why we're aiming for the easiest way. This is shell body. I don't care. Step. Ooh, I like step. Also, I think we get the mannequin. Oh, if it's easy, maybe we'll also keep the mannequin. Why not? Paris legs. What is this? We have a step. Yes. Like. All right. Let's insert here, not this, because I didn't see the mesh. Let's instead. I'd like these with mannequins because maybe the mannequin will also mesh, maybe, if we're lucky. This sitting mannequin step seems pretty complex because it opens pretty. The mannequin is problematic, let's say. The chair is simple, let's say. Can I do something for this mannequin? Oh my god, oh my god. Let's hope for the best, you know? This means. What is this? What is this? This is the tip of the shoe. Repair. Let's go here for stitch. And let's click yes. I would like to have a mannequin to simulate the person. Gaps. There are no and missing faces. All right. Here there are face shells inside shells, and it's not so nice topologically. It's not so easy for the software to calculate the void inside the void and everything that what should stay inside, what should be outside, what should be solid. It's not so easy to understand. Let's see, maybe it will work in the end. There is a problem with if I continue here, we'll lose this arm. Let's go here, stitch again, two stitchable edges, and gaps again, and missing faces, 7 missing faces. Ooh. We're going very well. What do we do with this one? I can delete it because I can mirror. Let's create the plane and let's mirror the arm here. Mirror, this is the arm and it will be mirrored. All right. Now let's look here and see what we have as a surface body here and this one here, no problem. Because I can mirror this, I can mirror this. So this one and this one, but the plane is not exactly in the middle. Delete, because I would like to mirror the entire palm here on the left side, if possible. So mirror, this is the plane, and I will select all these parts. I hopefully can. All right, something like this. But where is the... Oh, okay. Let's see now if I can merge all these parts. So now this is the final thing. Combine. Let's see. No, I want to merge this with this, with this, with this. Not possible, not possible. This. For the people wondering, there will be a drone entering an office window. I'm struggling to also include some witnesses, so please have some patience, and hopefully your patience will be rewarded very soon. Yes. With control test, yes, we're selecting all these parts. What is this? Can I select this? Yes. Here, can I have the mouth? Yes, and the eyes? Oh, yes. Also the eyebrows, not today. Nice. What is this? Okay, what is this portion? Yes. It kind of looks nice. The only thing that I don't... We'll just delete it. This cannot be joined with the other parts. And I hope now we have an entire body. Yeah, let's just delete this. That was the belt frame or lock, I don't know how it's called. Do these overlap? Interference. I'm thinking about the body if it collides with the chair. Yeah. And here there is a problem with this shoe. So let's move the chair. Something like this, all right. And here, can I join these? Yes. And this? Won't work. Doesn't work? No. It doesn't work. Do we care so much? No, we don't. Let's leave it like this. Yes, so we have one person. I would like to have this and this here. This will be the person, and this would be the chair. Yes. Copy the assembly. Close this and paste it here. All right, where? A few years ago, someone from ansys had the brightest idea to reverse shift with control, and now old experienced users, they mistake the shift with control. I will not comment too much, but of course it kind of reversed how we were thinking. Let's resize this, I don't know, 7 times maybe. So the anchor point will be this one on the drone, and we will resize the person, I said, 7 times. All right, let's do again the same thing. Resize the same anchor point, and I will choose the chair 7 times. Using the same anchor point, we'll have the proper. We'll keep the same orientation. We have a collision here, small collision. So let's move this downwards just a little. 5 millimeters should enough. Prepare interference. Now the hands, come on. Why do you do this? Design move. Prepare interference. Interfering. Perfect. Now let's put this person to work, you know? Too much time spent outside. Something like this. Where is the person? Let's bring the person in the office. Now with Control pressed. With Control pressed, we're duplicating the person. All right, so something like this. But you know, because the drone will enter only here, I don't care about duplication. Let's move this person here. Yeah. We can rotate the view if we drag this interrupted line. Oh, don't even tell me they joined again. The desks joined the building. Split body with this face. Combine this with this, but not the desks. The desks should be separate. All right, they are separate. I would like to bring the person and the chair more inside here, more in the under the desk. Yeah, something like this, because I would like to be impacted pretty quickly by the drone. It's not needed to waste time, you know. Something like this. So now I would like to bring this a little more to the right, if possible, because I would like to be impacted by the drone much quicker. Can I delete this now? Is it possible? Is it or not? Split body. I will split the desk with this face, and now I will bring this I set more to the right. 55, let's say, all right? And now these faces, I will pull up to U from the keyboard. U is up to this. All right. Now let's join again, this and this. Look here, right-click Show All. It's closer to the window. Yeah. Let's simulate a little. if I switch the anchor to here, can I somehow simulate the impact? Something like this. All right. But I'd like also the desk to be touched just a little. 2 degrees. All right. I predict that this person will have a bad day at work, but you know, there will be paid leave, no problem. Right click, update geometry from source. Something from the audience. Let's see. Mythical FYP pool. FYP pool. I think it's a praise or something. But let me see what it's FYP. FYP. New project. 5 years for a pleasure. Yeah. So, for you. For a pleasure, for a purpose. Yeah, it's to have fun, yes? Let's have fun and learn in the meantime. Yes. Definitely, there will be needed a virtual topology to unite the faces on the also on the mannequin here. There are multiple faces there. Look here, yes. And also lots of faces. They were healed and united. And let's hope we have an easier mesh. If not, we will just delete it. We will just delete it now. 0, the feature size, maybe 5 here. I'm keeping this 100. Let's keep it. Why not? I will close space claim. Yeah, thank you for the encouragement, Mr. Workpath. Maybe Warpath, something like here. Yeah. Yeah, some problems with this mannequin. Can I make here 3 and here 10 out of curiosity? Come on. Why don't you? Sizing. Does it work with 50? I will keep in mind there is the featuring of 10 here. All right, right click. This is the chair. This is the building. Oh my God. This is the desk. All right. Desk. This is the drawing. The building should be concrete. And let's choose a rubber for the person. Explicit materials. We have a concrete. It's not a container anymore. Weak concrete, 35 megapascals, and I said something about rubber for the person. Where is silicon? Silicon is not silicone with E, so I will choose here hyperrealistic model. Maybe this thing, neoprene rubber, maybe. Let's see if it works. Right-click, refresh materials, and we have the person made of neoprene rubber, chair, aluminum alloy, whatever, building concrete, desk aluminum alloy, and the drone is made of aluminum alloy. All right, so I'm behaving like the person is already meshed, but it's not meshed. Let's hope for the best. All right, there is also this trick, change if additive sizing to no, and maybe it will work. Let's see. It doesn't look like it's working. Let's test with 25, just for fun. Come on, mesh, come on. It's not even considering meshing. So additive sizing again with 25 millimeters element size. Oh, the feature. Can I assign, I don't know, 3 millimeters here and say hard? Come on, work, please. There is a tendency. This is a problem when you do something for the first time, and I didn't rehearse it before. 535. Oh, this looks easy. Solid part, this looks easy. And this other one. Parasolid, okay. What is this? Oh, it looks so nice. I need to make a leg for the chair, which it's not so hard. Let's download the Parasolid here. Come on. Why don't you cooperate? No, this is absurd to have 10 millimeters defeaturing. Let's use the mannequin with the back of the seat, the backrest. Do I have like an insert button? I don't see. Set geometry. Let's see. Where's, oh, here, okay. Minus 90 degrees, and we're pulling this person here. Minus 90 degrees. We're looking from above and here. Come on, yes. Let's design. All right. Let's make the rest, okay? Because the chair should not levitate. I do have some. Oh, too many radiuses here. Let's see, for example, if I double click here, can I delete this? Yes. Let's save. Can I select this protrusion and maybe delete it? Come on. Yes, please disappear. All right. What is this? It's part of the... It's a single part. Come on. Why? And also here. Why? I'm such a lucky fellow. Who's making out of an assembly a single part? Why? Why would you do something like this? Let's leave it like this for now. And also the chair. We need the chair. What is this? Iris legs? Ah. Lots of rounds here. Too many rounds. So here, file, open, and I will steal the chair from here. Here. Let me resize this 7 times. No. Yes. 7 times, I said. Oh, it might be too much. This was already resized. There will be a drone impacting an office. I promise you. With God's help, there will be a drone impacting the office. So please have patience, because your patience will be rewarded. Oh. Person is a little too big, too big. let's scale the person a little. Zero 0.88. Yeah, something like this. And resize a little the desk, the chair. 1.1. Yes. All right. So the person is uncomfortably staying on the chair. Let's see the building floor. Yes. The chair should definitely not levitate. Something like this. And now, oh, it looks so nice. Something like this. Let's go here for prepare interference. Found on area. Where? Ah, here with the floor. No problem. Let's instead bring the building down, if I can say this. How much? 5 millimeters maybe. And run the interference again. No interference. Okay. So maybe the chair does levitate a little. Control Z, and instead of, yeah, here is the interference. Instead of 5 millimeters, let's move it 2 millimeters. I don't want to obviously levitate. The chair should not levitate. Maybe people can levitate, but not the chair. Control S to save. And here, update geometry from source. We do have some small radiuses, but it should not impede our mesh. Person, let's suppress and let's see with the default. With virtual topology, we should heal some of the small faces. Let's right-click generate mesh and see what gives. Come on, it's not possible today. Today we should have a meshing mannequin. You know what? Let's delete the virtual topology. Maybe the mesh will work just like this, maybe. What? Oh. It crashed, it stopped. Hi, does this simulation similar to... Hi. We don't know. It's a drone, you know, it's not an airplane, so let's not think about bad stuff, you know. So let's go here and delete some of the radiuses from the mannequin. I left it default. And yeah, we should simplify it. We should edit it somehow. We should heal it. So there is a problem with this hand. Look here. If I right click, can I check geometry? Yeah. There is a problem. Yeah. Okay. Why didn't you say so from the start? Let's select this edge, assign a plane, split body, this body with this plane. Let's delete this half, also this whatever, and mirror. Before mirroring, can I can I delete some of the radiuses? Just asking if it's possible. Let's save before doing important things. Don't you want? No. All right, so here, can I delete this? Can I delete this? No? No, you don't want? Delete, can I delete this? Yes, but I hope we don't have problems here. I hope we don't have problems. All right, let's leave it like this. It looks pretty nice. Can I delete this face? Yes. Now let's mirror. Show all. Yes. Should be nice now. Save and double click. So the hand here on the finger side, it had some topology problems. I think we got rid of them and the mesh should go fine. Come on. The loading is quick because we have space claim opened. This is space claim. Let's close it. And this is the chair, while this is the person. The person is made of neoprene rubber. The chair is made of aluminum alloy nonlinear. Contacts now. Let's suppress and just attempt default mesh. Yes. $16,000. All right. Now the desk has problems. Why? Let's assign a sizing on the desk, maybe 70, and a sizing on the person, maybe 50. All right. The feature size 1. Right-click generate mesh. We have complete success. I'd like to leave the mesh not so coarse, all right. Let's see. So, finally. So what I was thinking about assigning an initial velocity on this drone on the faces, Control A to select all faces. No, the initial loads are on bodies, so Control B for the bodies. And let's assign a coordinate system. Along the Control E to select the edge. All right, so here for the x-axis, I will say geometry selection and select this edge. Apply. What don't you want? You don't want. No problem. No problem. We also have Control F. I can select this face. And for the X, I can select also this face. And it should become normal. Yes. Sure. All right. So I will go with minus x, all right? Here velocity, initial components, minus what? Minus, I don't know. Let's make it in meters per second. Let's make 100 meters per second with minus. And select the coordinate system that we just created, yes? And it goes like this. It's 300 and something, 360 kilometers per hour, I think. Let's do it like this. All right. We kind of have everything that we needed. 0.001. Yes, 1u minus 7 here and here. 5. Let's make here this one maybe 1. No for inertia nodes. 100 for number of points. Maybe closer to 0.7 to also achieve some braking. Some mesh erosion. And we're good for solving now. Total velocity, strain and stress. Control S and solve. Let's see. Let's also insert standard Earth gravity, which is minus y direction. All right. Save solve. What solving time will we have? So I assigned the density for the rubber. Let's see if it works. Maybe it also requires a Poisson ratio and Young's modulus. We will see if it will require. So it works. There are no errors. Let's see if the end time is big enough, or maybe we need to extend it. We can calculate a little, you know. Look here. I need the drone to go for 2 meters, yes, and we're going to do something like this. I know that I have input 100 meters in 1 second, and because I need 2 meters, what what should be the end time? Yes, x is 2 meters multiplied with 1 second over 100 meters. We reduce this, and it's 2 over 100 second. This means 0.02 seconds. So this is why my end time 0.001 is too small. Yeah, this is why also the solving time is so fast, because I need to increase the end time. It will displace, but too little, you know, only this. And I need it more, yes? Let's stop. what I will also do is I will increase a little here. We need to increase the end time with 20 times, and this will increase the solving time 20 times. 20 multiplied with 2 is around, it will be around 20 something minutes, 20 minutes and something. So a small trick would be let's leave it like this at this moment in order for you to correlate, to properly correlate with what I said. Yes, I'll make 0.02 in order for you to believe in my calculations. Then we will increase the velocity and shorten the end time for faster solving. So this solving will take around 22 minutes maybe when it will begin to work. Yes, so it multiplied with 20. And because we don't want to wait so much, let's increase the velocity with 33% and decrease here 0.012. And we maybe will be around 15 minutes of solving, maybe, which we can accept. We can have patience for 15 minutes. Yes. All right. How we will look on this CFA will look something like this. We'll create a section plane here, and we will look here like this. This is how we'll look at the behavior. Yeah, so can the results of this simulation be exported and used to deform a higher quality mesh, such as for physical accuracy effects and models? The results can be exported as STL. Yes, so here you have, I cannot right-click at this moment, but you can right-click here and export results, and usually they export as STL. And you can use the STL further. Yeah, because Maya Blender, they use STLs. Yeah. The answer, my answer is, I think yes. Let's see if we have ansys drawn. What can we learn from our colleagues? Design and analysis. This is, what is this? I'm thinking how it obtained this, like an animation, but no, it's a camera movement, I think. Ansys wavelength. I want impacts. Modal analysis, the easiest thing to do. You don't even need a fixed support for model simulation. Get into the drone simulation zone, but nothing, no impact, no, come on. Flow, only flow. Oh, it's a good thing that I made this. That I'm making this simulation. No impact. Ansys plane, but not CFD. Real time, 6 DOF movement. Brake pedal. What is the connection with plane? CFD, 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 no impact. Well, why don't you show impact? Why? So where are we? I should have left like a laptop here. FSI simulation. What? CFD with static. I don't know. Impact, plane impact. Yeah. Yeah, not so much. Impact simulation. This is nice. Yeah, it's so nice. How come only one like in 6 years? Come on. It's so nice. Such a nice simulation. It's nirvana. Superb. Oh, this is something that I would like also to do with a Kevlar vest or something similar. Also, this thing I would like to do because I have the geometry for chainmail. This is nice. Very nice. With a coupled Eulerian Lagrangian, yes. Very nice. So nice. Ah, and the bullet stopped. Here is the previous bullet, and here is the present bullet. And this one drops, and this one flies upwards until it will drop due to gravity. Superb simulation, yes. Oh, I kind of double-clicked. This I wanted to see, and this one, yes. Yeah, very nice. Oh, I think this person has a bad day, I think. Definitely, yeah. Oops. I think the person needs a medical leave. 7 more minutes. Pretty expensive. So I have like a top. Oh my god. The price is 22,000 kilometers. Oops. This is a shorter movie, let's see it. Yeah. So the drone design development, innovation advanced so much in the last years due to the current conflicts and threats. Let's hope we'll also have peace on this planet sometime when we deserve it. Oh, this person definitely has some problems. I'm wondering if there will be time for this crash also to appear here. We'll see in a few minutes, then we will successfully finish this. this live stream. Do you have any other questions? No? One watcher, perfectly. Let's watch together. Something about drones. Do we have something to learn from someone? Of course we have, but we cannot see something. This is ILS Dyna, yes. This is Hans. This is Hans from ansys. Ooh. It even has the different, let's say, annular rings density here in the disks. There are like annular rings with different material properties in the cartilages here in the disks. And yeah, if this comes already modeled, then ansys have done a great job with Hans, with the Hans geometry, the Hans mesh, yeah. So they're showing something Nirvana. The thumbnail is Nirvana, and they are showing something pretty basic. Yeah. So it's successfully solved. Let's see what we have. Oh, yes. I will extend the solving from my side. I will extend the solving. I will extend the solving, and yes, I will present this FEA on my website in the next few days or weeks, because it looks so nice. So this concludes our live stream, and yes, we had lots to learn regarding the geometry, the meshing, the procurement of a good model, and applying easy loads. Thank you for the reaction, and for staying with us. Yes, have a nice day. Bye-bye.